Hey guys, this is Mrs. Keith. I was just going to go over a few problems on each of the notes or practice this time. Not the notes, but just the practice, just to make sure you have some extra help. I want you to remember that 180 degrees is the same thing as pi radians. So if you're going to convert degrees to radians, you can multiply times pi over 180. That way you're canceling out those degrees and you'll be left with radians. So for example, this 90 degrees right here, you can take 90 degrees and multiply it times pi radians over 180 degrees. That way your degrees cancel out. Technically this is 90 over 1, so that will become 90 pi over 180, which simplifies to be pi over 2. So pi over 2 radians is the same thing as 90 degrees. All right, let's do 300. So 300 degrees, we'll multiply it by pi radians over 180 degrees. That way your degrees cancel. This is understood to be 300 over 1, so you'll get 300 pi radians over 180. 60 goes into both 300 and 180, so that's going to simplify to be 5 pi over 3 radians. Okay, so I think that should help for the rest of these this practice. Let me do the other one, or a couple of examples on the other one. Okay, remember that 180 degrees is the same thing as pi radians. So honestly, if you've already got pi in the equation, just replace it with 180. So 180 divided by 4 is going to give you 45 degrees. If you did it the long way, you could say pi over 4, and this time you're going to multiply with 180 on top because you want to be left with those degrees, and you'll have pi radians on the bottom. Now these pi's are going to cancel out. This was already in radians, and the radians will cancel as well. And so you're going to end up with, from here to what that is anyway, if you just replace that pi with 180. So anytime you're converting from radians to degrees, you can just replace your pi with 180, and that will tell you what the answer is. So here, 5 times 180 divided by 12, that's going to give me 75. If you did it the long way, you could say 5 pi over 12. You're going to multiply it by 180 degrees over pi. Your pi's will cancel. You multiply 5 times 180 and then divide it by 12, and you're going to get 75. Okay, I'll do the next one. Okay, just a reminder, you have notes on all of these, and all of the answer keys are also going to be found on Canvas. This set of recordings is just intended to help you in case you have some extra problems. All right, so Mrs. Green did a set of notes that talked about arc length and using it with radians, and she meant for you to realize, that this is the formula we're supposed to use. Anytime you want to know what the arc length is, if you've got the angle in radians, not in degrees, you can just do the radius times the angle. But again, this has to be in radians. So her notes went through explaining why that happens. Basically, you have the arc length equal to the angle divided by 2 pi. We're using 2 pi because that's a full circle. And you multiply it by the circumference, which is 2 pi r. The 2 pi's cancel, and you're left with that theta r. Okay, so here, on the next one, they're saying the arc of CD is 1/4 of the circumference of the circle. So if it's 1/4 of the circumference, you're basically just going to do, and they want to know what is the radian measure of the central angle. Well, it's going to be 1/4 of the full circle. And 1/4 times 2 pi is going to be 2 pi over 4, which is just pi over 2. Okay, on the next one, it says consider circle T with a radius of 24 and an angle of 5 pi over 6, and it's in radians. What is the length of the arc? So you're finding the arc length, which means you're going to do S equals R theta. I have no idea why they choose to use S for arc length, but they do. Maybe it's because it's subtended. I don't know. Anyway, so S is going to equal, the radius is 24. The angle measure is 5 pi over 6 in radians. So you're basically doing 24 4 times 5 pi divided by 6. And that's going to simplify to be 20 pi. You'll do 24 times 5 divided by 6 and to get the 20, and then you'll just attach the pi at the end. Okay, this one you have a radius of 11, and it has an arc length that is 7 centimeters. So that is 7 centimeters. That's the arc length, not the arc measure. And they want to know what the angle is. So you're going to use your formula, S equals R theta. You know your S is 7. They told us that was the arc length. Your radius is 11, and you're trying to find theta. So basically, you're going to divide both sides by 11. This is an exact answer. This question is asking you to round it to the nearest tenth. So when you put that in your calculator, you're going to get 0.6 radians. All right, let me scroll this up a little bit. Okay, on this next one, it's told the arc length is subtended by an angle of 7 pi over 4. The length of that arc is 21 pi, so this is 21 pi. And the angle measure right here is 7 pi over 4. All right, what is the length of the radius? So again, you're using this formula. You've been given the arc length that's 21 pi. You're looking for the radius, and your angle is 7 pi over 4. All right, you're trying to solve for r. So right now r is being multiplied by 7 pi and divided by 4. So I'm going to do the opposite of that. I'm going to multiply both sides by 4 and divide by 7 pi on both sides. On the left-hand side, 7 pi goes into 21 pi 3 times. Over here, it all cancels, and so you're just left with 4 times 3, which is 12, equals the radius. I probably should say 12 feet. Sorry about that. Okay, on the next one, it says consider this has a radius of 6. And what is the area of the shaded region? Okay, I'm going to do a quick lesson real quick just to remind you. The area of a sector equals the angle divided by the full circle. Remember in radians, that's 2 pi times pi r squared. Your pi's are going to cancel. And so a shortened formula would be theta times r squared over 2. And that's what we're going to use right here. So we've been given the angle. It's 2 pi over 3. The radius is 6, and you're going to square it, and all of that's over 2. Okay, so technically, I'm going to write down below, sorry. Technically, you've got 2 pi over 3 times 36, and that's understood to be over 1. All of that's over 2. Well, 2 pi times 36 is 72 pi divided by 3, all over 2. 3 goes into 72 pi. It goes in there 24 pi times. You still divide it by 2. So your answer on this one is going to be 12 pi inches squared because it's area. All right. I'm going to clear that off and then do the last one. So the last one, again, we're using the area formula that we just talked about, which is theta times r squared over 2. It wants us to find the area of the shaded region. This is the angle, 1.6. The radius is 5. You're going to square that and then divide by 2. So when you multiply all of that out, you're going to get 20 centimeters squared. Okay, so that's how to work those. I was hoping maybe that might help some of you that can't attend the Zoom tutorials. I'll be available on Tuesday and Thursday at 2 o'clock to do Zoom tutorials again if these don't make sense. Thanks.